As you all have seen in this 2024 Tesla launch, Tesla has launched a robot taxi which can go charge by itself using wireless charging. In this video, let's find out how actually a wireless charging works and how practical is wireless charging. Before we jump in, let's learn about the history. Wireless charging is also known as inductive charging or cordless charging, which means power is being transmitted wirelessly to another source. But this technology isn't new. In 1972, a professor from University of Auckland proposed a theory of doing wireless charging. In 1977, he was awarded for his patent on electromagnetically coupled battery charger, where he described for the application as charging the batteries for miners. It's been already 4 decades for this technology to grow up rapidly that we're using in our cars. We even use in our mobile phones. Apple has this wireless charging. Have you ever wondered in some videos if you see when you throw some sand on back of an iPhone, you can see sand collecting in the form of circles. Basically, that's iron coming close. Electromagnetic field which is generated behind the iPhone, which lets the iron particles to stick around the edges. So that's a significant improvement in the technology for the last 4 decades. But now we're seeing the technology go even further for charging electric cars. And Tesla redesigned this whole thing, made to transmit more than 100 volts and charge the whole vehicle wirelessly. Let's see how this contraption works. Here we have this circuit. This is some basic diodes and transmitters connection. It's a basic layout connected to the copper wires. These copper wires have been 8 times wounded and connected. So the input for this is 12 volts. And using an adapter, receiver connected. So when the transmitter is turned on, this blue light turns on, telling that the transmitter is ready to transmit the power. And here we have the same LED blue light indicating that if it receives some power, it will start glowing. Same number of copper windings over here, and I have a small basic circuitry with diodes, resistors, and capacitors, and some inductors and a transistor. I made it on a plexiglass so that you guys can see underneath. There is no batteries, and I have these two wires coming out and extended them with positive and negative for us to measure how much actually the voltage reads out. Okay, now let's demonstrate how this thing works. When I plug the charger in and connect the wireless transmission, you see already it's far. Let me move it far. I'm seeing this blue light blink. The transmitter light is blinking. Let's quickly measure the voltage of how much it's showing. So if I flip it in the back, I have positive and negative. So I'm just connecting it. And you can see it shows 11.41 volts. Now, so this is technically transmitting 11.41 volts from here also. Now, if this receiver has nothing connected, it's in the air. Once I start moving it down, the light starts glowing. It glows. So here the intensity is very low, you can see. And when you keep going down, then it starts getting more and more intense. The LED blinks more. This says that it's the transmission of the power is happening and it's charging wirelessly. We can measure the voltage, but if you see, if I move it up, it's slowly decreasing. And move it back down again, it's full glow. Now, let's measure the voltage at full glow. This is a full glow. I have my multimeter right here. As we are getting only 6 volts when it is completely flush, which means it's touching completely to the receiver and there is no gap between the transmitter and receiver, we're still getting 6 volts. We're having a 50% decrease in the voltage. That is common because when you're transmitting wirelessly, there are some losses which occur, which is in the form of heat, which is a common thing for electric vehicles. In EVs, there's a battery controller and a motor. There is no media in between, but it produces a lot of heat. One loss is heat, and the other major factor is the number of windings. With my circuitry, we're just receiving 6 volts, which is half. And when I move the base around, let's see how many actual volts we get. Now, when I keep moving up, it drops to 5, 4, 3, 2, 1, and the light is not even blinking, but we still see some voltage, very less voltage. But when I kept going down, you see when there is a light just a little bit glow, we see that it's 2 volts. We keep going down more, we see constant 6. So at this height, we almost get full voltage. Demonstrate this on a car. I bought this dune buggy for 10 bucks and just made a slot to demonstrate how a Robo Tesla works. This is our Robo Tesla for the day and see how it works. So this is our contraption where, let's say, the charging is underneath. The wireless charging for the Tesla is like on the base. When it's coming back, it gives us full voltage. Like if the car is exactly aligned to the wireless charger, then we get a full volts of 6 voltage. That's good. But what if there is some obstacle? It's always blue on theoretical, which means it's always perfectly aligned. What if it's not? So let's say the Tesla is pulled back, moved away. So we were getting 6 volts, now we are getting only 5 volts with just sliding over a little bit in the front. It's not completely back, but it's still charging. We're having a loss over here. It's not exactly flat on the plane. It's not parallel, but parallel from another side, but trying, and it stopped. It couldn't go. You see, we almost lost half. We were at 6 volts and now we're at 3 volts. Loss of transfer can also happen with the car material which surrounds the receiver. For example, this has poor thermal conductivity materials like plastics, heavy plastics or heavy metals, which can affect our wireless charging. It's a very simple concept when you apply for low voltages like 12 volts to 24 volts. But applying for 100 volts like a Tesla battery, that's a complicated process. And to achieve maximum output out of transmission and receiving and without any losses, that's a great way to go. And Tesla hasn't announced how it's going to work, but this is how our inductive charging or wireless charging works. If you guys like this video, please leave a thumbs up and subscribe to the channel, and we're going to learn more about electric vehicle stuff. I'm building up a broken scooter behind me, so I'm going to make it two-wheel drive. So for that, subscribe to the channel. I'll see you all in the next one.